Okay, let's look at problem number 69 from chapter 27, capacitors and batteries. And the problem is a 9-volt battery is connected across two capacitors, CA of 12 microfarad and CB of 3 microfarad, and they are connected in series. So the equivalent capacitor of series combination is this. So 1 over C equivalent equals to 1 over CA plus 1 over CB. So that equals to 1 over 12 microfarad plus 1 over 3 microfarad. So whenever you do small simple calculation, you will get 2.4 microfarad, that is 2.4 times 10 to the power minus 6 farad. So this is the equivalent capacitance of series combination, and this completes the question for part A. For part B, so it asks about the energy stored by such an equivalent capacitor. So total energy stored by this equivalent capacitor is 1 over 2 C equivalent B squared, that is 1 over 2. So we have this amount of equivalent capacitance, and this is the battery supply, and it will be this, which is the required amount of energy stored by the equivalent capacitor. So this completes the part B. And for part C, so the question asks you to find the total charge on each of the capacitors. Okay, so as we know, in series, the charge for the capacitor A and charge for capacitor B is equal, and they are equal to the total charge of the equivalent capacitor. So as we know, the totals are Q total equals to C equivalent times B. So this will be 2.16 times 10 to the power minus 5 coulomb. So this will be the total charge on each of the capacitors, which will be equal. Okay, so this will be same for QA, and this will be also same for QB. So for part D, so question asks you to find the energy stored in each of the capacitor in the circuit. So energy stored in each of the individual capacitor would be, let's say for capacitor A, the energy stored would be UA, which will be equal to half QA over CA square. As we know, this QA is same as Q total, so we can use this amount of charge. So whenever you do simple calculation, you will get this amount of charge, which is the amount this amount of energy, which is the energy stored by the capacitor A. Similarly for capacitor B, so capacitance for this capacitor is 3 microfarad, and you can use the same idea as we used in part, like used to calculate UA. So you will be able to find the total energy stored by the capacitor B. So this is how you can solve this type of problem involving capacitors and the battery supplies.